All right, guys. Hey, welcome back to my virtual classroom. Today is Wednesday. It's actually not Wednesday, but it's Wednesday, the Wednesday of the science presentations. So I'm going to go ahead and record the second part of your egg drop and egg soup project or egg soup project. Today, if you're watching this video, this is going to be so easy. You should be able to finish this thing in no time. Because basically I'm going over how you get all the answers to components number 2 and 3. Component number 1 was simply turn in a before picture and after picture of your egg compartment. So let's start off. Suppose this was your egg compartment. It met the criteria, which was 8 inches long and 6 inches wide. So this little Morton iodized salt container works just fine. I mean, it doesn't have crumple zones, but it's a good representation. The first thing we're going to do for component number 2, which is in the middle of your rubric, and by the way, I have the rubric on the Google Classroom. It should be with this assignment, and it was also with the assignment last week that I posted. So the second component says the students will be able to show me that you know the law of conservation of energy through this project. So real quickly, let's take a look at what you guys did. First of all, if this was your egg compartment, and again, we didn't have the 2 kilogram mass on the top because you guys did it at home. You had it fall down, your egg was in there. The energy it had at the top was gravitational potential energy. As it fell down, that gravitational energy was converted into both kinetic energy, and it still had gravitational energy, but the gravitational energy decreased as it went. And then finally it hit the ground, and it had only kinetic energy right before it hit the ground. So I'm going to go ahead and write a depiction of what happened. It started out with gravitational potential energy on the top. As it fell down, it gained kinetic energy. So the kinetic energy increased as it fell, and the gravitational potential energy decreased. And then right before it hit the bottom, it had only kinetic energy, and that kinetic energy is what was transferred into your mechanism, and hopefully the mechanism absorbed it, not the egg. So let's go ahead. On the first part of this one, it says calculate the gravitational potential energy. Well, you guys remember the equation for gravitational potential energy? I'm going to go ahead and use a different color. Gravitational potential energy, the equation was GPE equals G-H, mass times gravity times height, right? So I'm going to talk quickly because I want to get through this presentation so you don't have to watch a lot. Then it says calculate the kinetic energy of the object right before it hit the ground. Kinetic energy, the equation is mv squared divided by 2, or 1/2 mv squared. Oh, so by the way, look at masses in both of these equations. Since you guys don't have a scale at home, we're just going to say everybody has the same mass. I'm just going to pick a number out of the air. Let's say the mass for this project, for all your calculations today, let's make it 0.7 kilograms. So we're going to pretend that was the mass of your project before it fell down. Okay, so far it seems pretty easy. I go to the middle part of this rubric, using the law of conservation energy, show all the steps used to calculate the velocity of the compartment upon impact. Ooh, we want to know the velocity, not here, not here, not here, but right before it hits the ground. So how do we do that? Well, it says use the law of conservation of energy. So, law of conservation of energy, I'm going to go back to blue. Law of conservation of energy basically says the energy we start with is equal to the energy we end with. We'll ignore any losses due to friction or air resistance. So, what do we start with? Gravitational potential energy. What do we end with? Kinetic energy. So, how do you solve for the velocity? Let's put in our equation representations. Gravitational potential energy, mgh equals mv squared over 2. I'll tell you what, as long as I'm flowing, I'm just going to quickly do the algebra, and then you guys will be able to just throw in your numbers. Let's see, would a heavier object have more velocity upon impact than a lighter one? Watch what happens. We've done this in class, but I'm just refreshing your memory. To solve for velocity, remember velocity is in the top, so we can just leave it alone, leave it right there. Let's get this 2 to the other side. So to get the 2 to the other side, I'm going to use a different color for the algebra. It's dividing into there, so we'll multiply both sides by 2, which cancels it out there. So now we have 2 mgh equals mv squared. So now we got to get rid of this m. Here's the m. Here's the m. Bring it over the other side. It was divided, right, by each side. Cancels out there. Oh, looks like I just answered that question I said earlier. All of your objects, if we were in class today doing this, they would have all had the same final velocity. So the rest is basic algebra. We have v squared equals 2gh. I'm going to rewrite it here, and I'm going to put v squared first. V squared equals 2 times gravity times height. To get rid of this squared, you just take the square root of it, which gets rid of that, which is that. So, for that middle part, you just saw all of the steps. Write them out, or just plug in your numbers when you turn in your assignment. Equals the square root of 2 times gravity times height. By the way, gravity just used 10, so you don't have to worry. All right, so now, the last part of that middle section is write an explanation of all the energy conversions which occur from the drop to hitting, from the top to the drop. If you paid attention to what I just said here, you can put that into words for me. Okay, in the very last part, third component, we're covering Newton's 3 laws, conservation of momentum and impulse and momentum. You see them right on your rubric. The first part asks, explain Newton's explanation of Newton's 3 laws and evidence during the collision with the floor. Okay, pay attention. I'm not going to write anything down. It starts at the top. Pretend my hand is the floor. As it comes down, it hits the floor. We're talking about this moment right here. So, Newton's first law. A body at rest or constant motion will remain at rest or constant motion unless acted on by an unbalanced force. Okay, there's your hint. What's the unbalanced force? So, Newton's second law. An unbalanced force causes an object to accelerate in the direction of the unbalanced force. Put it in your words. And the third one, for every action force, there is an equal reaction force. Which one had the greatest impact energy? Don't say this, and don't say the floor. You know the answer. Okay, and the middle part of this, calculate the momentum of your compartment prior to collision with the floor. In case you don't remember, the equation for momentum is P, which represents momentum. I'll put a vector sign over it. P equals mass times velocity. Do we know the mass? Do we know the velocity? Yes. Then it says, calculate the impulse. Well, if you remember the impulse momentum theorem or equation, basically we found out in class that the momentum is the same thing as impulse. J is the symbol for impulse. P equals J. If you just calculated that momentum, you just calculated the impulse. Momentum is the same thing as impulse. Pretty easy way to get those points. And the last one, the last part of this write-up, explanation of how the concept of impulse and change of momentum are key factors in designing your crumple zone for a safety system. Well, if you designed your crumple zones correctly, this concept right here, impulse, spreading force out over time, saved your A. Put that in words for me right there, and you've got, this is worth 9 points. The middle part, that was worth 9 points. And if you turned in your 2 pictures, you got 9 points there. So, that's how you do your lab write-up. Please put them on a Google Doc. Send it to me. I know it's kind of a pain to draw out calculations. So if you just show me the answers you got, I'm cool with that. All right, guys. Thanks for listening. Spread the word for everybody to follow this presentation so they can get an easy A on this assignment. Okay, talk to you later.